Calculate the shaded area of this shape. So we're looking for the area of this blue section. So what we have is a trapezium, and then we have a right angle triangle, and we're trying to find the area of the inside part. So step one, we're going to find the area of the unshaded triangle first. So we're going to try and find the area of this little triangle at the side. We're going to use Pythagoras Theorem to find the length of the triangle's base. So if this is 12, then this is also 12. So we can label this as 12. This is 13. And now we're going to try and find this distance up here. So Pythagoras' theorem is c squared equals a squared plus b squared. The c squared is going to be 13. 13 squared, because the c is always the longest side. The a squared is going to be the 12. And the unknown side we can just leave as b squared for now. So c squared equals 13 squared. A squared equals 12 squared, and then the b squared stays as b squared. 13 squared is 169. 12 squared is 144, and again b squared stays as it is. 144 comes over the equal sign and becomes minus 144. That's still equal to b squared. 169 minus 144 is 25, which is equal to b squared. So b is going to be the square root of 25, and the square root of 25 is going to be 5. So b equals 5. So this distance here is 5 meters. So now we can use that distance to find the area of that triangle. The area of a triangle is half times base times height. So we're not going to use the 13 because the 13 is technically the slant height. So we're interested in the perpendicular height, which is 12. And we now have the base, which is 5. So half times base times height, half times 5 times 12, 30 meters squared. So the area of this little triangle is 30 meters squared. So now we want to find the exterior shape, which is a trapezium. So step 2, now we can find the area of the whole shape, which is a trapezium. So the formula for the area of a trapezium is half a plus b times h, or area equals a plus b divided by 2 multiplied by h. So these two formulas mean the exact same thing, but the one on the right is the one that's in our formula book. So the a and the b represent the parallel sides. So if this is 25 and this is 5, then 5 plus 25 is 30 meters. So this parallel side is 30 meters, and then this parallel side is 20 meters. And the height, the perpendicular height, is 12. So we're not interested in the slant height of the trapezium. We're not interested in the 13. We're only interested in the perpendicular height. So it's going to be a plus b. So 30 plus 20. 30 can be labelled as a, 20 can be labelled as b. So 30 is a, 20 is b, and the height is 12. So using this formula, it's a half times 20 plus 30 times 12. 20 plus 30 is 50, and 50 times 12 is 600, and half of 600 is 300 meters squared. And then using this formula, so we get 20 plus 30 over 2 multiplied by 12. 20 plus 30 is 50 over 2 multiplied by 12. 50 divided by 2 is 25 multiplied by 12, and 25 times 12 is 300 meters squared. So step 3 is we find the area of the shaded shape. So that's going to be the total area, take away the unshaded area. So it's going to be the area of the big trapezium, take away the area of the little triangle. So it's going to be 300 meters squared minus 30 meters squared. And that leaves us with 270 meters squared. And just note, be careful when you're dealing with centimetres, metres, millimetres, etc. 1 metre equals 100 centimetres. We have to learn this off by heart. So 1 metre squared will be 100 squared, which is 100 times 100, which would be 10,000 centimeters squared. So 1 meter squared is 10,000 centimeters squared, and 1 centimeter squared would be 100 millimeters squared.